You can read this slide later. I will send you already. So for the Trimmomatic, what problem we faced in the report, we identified in the report, we will use a specific command or a specific parameter to remove them. So most usually used some parameter is illumina clip. It actually used to remove the adapter contents. The leading it used to trim the parameter from the 5' end, and for the trailing it is used to trim the low quality bases from the 3' end. And we have the sliding window and the mean length. When we do the analysis with a large file or large reads, it actually hard to understand the thing. So what we will do, we will perform the analysis on a single small size reads, that is this one, and we will check how it actually happens. So this is the sample.fastq file. What we had in here, I just first explained what it actually contains. It contains some polyethylene here that has low quality in it, contains the N contents here, also the polyethylene. It contains low quality bases at first. Here we can see some low quality bases and how we can trim that. So first we will work with the leading and trailing command. We had this is the tool name Trimmomatic, and we are performing on single end file, and we need to specify the mapping quality matrix. We are using the PS33. Then we need to specify our input FastQ file name, that is our sample.fastq. Then the output file name, okay, it should be inside the data directory, and we want to specify the output file name. It will be inside the trim directory, and we can specify the output file name as sample_trim.fastq. Okay, I'm just writing this, that is the leading tree and what it will do actually. So let's calculate this first by manually, then we will check the output running the tool. So leading actually cut or trim the bases from 5' end. So this is the 5' end, 5' to 3'. That is, it will go left to right, and if it finds any low quality bases, it will remove them. So we specified the trimming leading threshold as 3. If we take read 1, for read 1 it actually contains I that has the mapping quality score 40, and 40 is greater than 3, so it won't perform the leading for this read 1. So read 1 will be as it is. For the read 2, it will also be as it is. That is, it contains the first base as I. For the third base, it will be as it is. Okay. So for the read 4, we can see for the first base, we have hash sign and it has the mapping quality score 2. So it will be trimmed. After that, it will proceed for the next base and it will be trimmed also. Then the next base, next one. And after that, it found actually I and it has the mapping quality score 40. So the leading will be stopped in here. And for the read 5, we don't see any effect, so it will be as it is. So we only will see the effect for the read 4. So now run the command and check what we have actually. So after that, we need to actually check this. So we total have 5 reads, and after trimming, all 5 reads are survived, and Trimmomatic didn't drop any read. We check the out. So as we see actually, the read 1, these are the same. And for the read 4, okay, look at the read 4 actually. And here, this is read 4 in here and read 4 in here. So it removed the first 5 bases and we don't see hash symbol in here. This is how the leading command work actually. For the trailing command, we can see the same thing. Leading command performs left to right. The trailing command performs right to left. So we will see effect for the read 1. That is, we won't see these bases. Also, don't see this one, and it will start from here, and when it will get the first bracket sign, we can check the score of the first bracket sign. So here is the first bracket sign. It actually contains 7. It has the mapping quality score 7. So 7 is greater than 3. So it won't remove. So it will start from here and will stop in this position. And it won't have any effect on the read 4. And for the read 5, it will trim this. So let's try the trailing command. So this is the mapping. This is the score, the threshold 3 we are using. We can use the threshold as much as we need actually. We can use 7, we can use 10, we can use more higher, 20, 25. It actually depends on the read or what quality we are expecting. So if we run this and reload this file, we can see the effect in here. It removed. So these are remove expected, and we can see it is stopped in this first bracket, and here it is as it was. For this one, it removed the hash symbol. And if we can run the leading and trailing command together, that will perform the both things. That is, it will trim from the left to right, right to left. So we had seen this already. Now we can check for the min length command. We need to specify the minimum length. Okay, so if we run this, minimum length is actually after trimming. So we, after performing the trimming, the read has some length. So if we see this read, it has 9, it has length 9, it has some length. So what length we will specify in here, the 36. If the length is less than 36, it will be dropped actually. So the Trimmomatic dropped one read. We can check which read was trimmed actually. So read 5 has been dropped after the trimming, as it has the length 9, that is actually less than 36. So are these three parameters, leading, trailing, and mean length, these are clear? Any question on these three? Okay, Isaac, you can tell me where is the problem actually. Okay, so here we have the FastQ file. This is the original file. For the original file, we have low quality scores. Usually we have low quality scores at the beginning and at the end. So for the read one, we don't have any low quality scores at the beginning, but we have it at the end. For the second read, we have low quality scores at the end. For the third read, at the end. And for the fourth read, we have low quality score, low quality bases at the beginning. And for the read 5, we have at the end. So we need, when we want to trim these low quality bases, so we want to trim low quality bases, and when we will be expect to trim these bases, we will use leading and trailing. So this parameter will remove these low quality bases. So leading will do this like check from left to right and will trim the bases, and trailing will check right to left and will trim the bases. And after trimming, Trimmomatic will check the length of the read. After trimming, the length is less than 36 or specified length, then it will drop that read. And after that, we can proceed with the adapter content. How can we remove the adapter content? So for this sample, we have one adapter content. If we look at here inside our adapter file, the adapters.fa, that is this adapter file, appeared in this sample.fast. So if we search that, we can see the exact match of this adapter sequence, and other read may contain also this adapter sequence. So adapter sequence may have exact match, may have a little mismatches with the read, and also it may have some partial amount. So now we can proceed with the adapter content, how we can remove that. Okay, so for the, so we specified the trailing parameter as 3 in here. We specified the trailing parameter as 3. I just told you that hash has the mapping quality. We can check the mapping quality in here. Hash has the mapping quality 2, so it less than 3, so it will be dropped. And for the first bracket, it has the mapping quality score 7, but we specified 3 as a trailing threshold, so it won't remove actually. So it will stop. It will remove right to left, and when it will get the first bracket, it will stop in here. And if we would specify the trailing as 7 or trailing as 8, then it will remove these all bases and will stop in here. That is, the I has the mapping quality score of 40. For the adapter content, we need to use the Illumina clip parameter. Illumina clip. After Illumina clip, we need to specify the adapter file name. That is, when a sequence is done, so the sequencer machine what adapter it used or what all sequence it used, it actually lists them in a file, in a FastQ file. So we can collect that file and use that in here actually. I will just show you for our read. We can see the score in here. So we had next era transpose sequence, and for to remove this adapter, we will use this one actually, next era paired in sequence. And if we had any Illumina sequencing, Illumina universal adapter, that is this one, Illumina universal adapter, if we have any, then we can use this one, the TrueSeq AC for the single in mode and TrueSeq S3 for the paired in mode. So our adapter file path is in adapter. So after Illumina clip one clone, then the path to the adapter file, then we need to specify the seed length, then the palindrome mode, palindrome clip threshold, and after that simple clip threshold. So what does this mean actually? Here we had adapter sequence and we search all the adapter bases in this sequence. So when we specify seed length 2 in here 2, what Trimmomatic do actually, it takes first two bases of adapters just like this, and it actually starts the two bases in each read. So here we can see some mess in here, and if it finds some mess, then it align the all other. That is, when it finds AG in here, then it will take all the other bases in. We can see in here, it will base the entire adapter sequence with this actually. So this is how the seed actually works. And after that, the palindrome clip threshold, it's actually used for the pair in read and the simple clip threshold. So we can consider them as a the adapter sequence will be aligned with the reads. So after aligning, we will have some alignment score. So if the alignment score is less than 10, then we won't trim the adapter content. But if the alignment score is greater than 10, we will trim that. So we can see we have the exact match for the read 2. We found the exact match for read 2. So the read 2 will be removed after that command. And if it has some read that has the alignment score greater than 10, then it will be removed also. If we run this command again and reload the output in here, so we can see the read to in here. So how it actually works, if we take this adapter and search in here also, we can see matches this position. So when we found an adapter and where it matches, so from the start position to the end, all the bases will be trimmed. When you find any adapter content, then the from the first base to the end, all the bases will be removed. So for that reason, we just for this one actually. And for read 3, read 4, so read 3 and read 4, we don't have any adapter messes. But read 5, it actually finds some mess with this region. So it removed that. And after removing, we got this sequence. So after the removing the adapter sequence, we can check the sliding window. So sliding window works like, so the first parameter, that is the 4, it actually the number of bases the sliding window will each time perform. And if the 20 is here the mapping quality, average mapping quality. So if we look at the original sequence in here, we specified 4, so it will take these 4 bases at first, then it will sum up all these, that is 40, 40, 40, 40. So all the mapping quality for the 4 bases, and it actually 160 and 160, then we need to take the average of 160 is 40, and 40 is greater than 20, that is our threshold 20, so it's fine. And after that, it will go like that, just 4 bases, then the next 4 bases, something like this. And when it will come here, so when it will come here and it got some hash, it will actually survive, that is 40, 40, 40, and then 2. So the average will all again will be greater than 20. But for this one, that is 40, 40, 80, then 84, and if we average that, we also has the 21, so it all again greater than 20. And for these bases, it will fail actually. So here we have 40, then 46, and if we take average of 46, it will be less than 20. So when it gets some low quality, that is sliding window goes like that, and it checks the mapping quality threshold, and if it founds anything, and where it founds in that, this is the start region, and from this start region it will remove all the things through the end. So it's also like the adapter content, from the start position where it matches or where it found, it will trim all the bases to the end. And we can see what actually the mapping quality of F. For F, it actually 37, so we can expect that it will remove from this position at the end, and for this base it will remove from here to the end. Okay, we can check by running the tool now, and for this we won't see from here. Now if we run and check what we get actually, okay, we can see we don't have this, we don't have as we expected actually. So this is the way every parameter in Illumina, every parameter in Trimmomatic tool actually works. So this was for the sample FastQ file. Now we can proceed with our these reads actually. That was our original document. So we can see what we need to fix actually. Per base sequence content, here we can see it has some fluctuation. Okay, we can go with the single in first, and Trimmomatic, that is trimming, won't actually fix this. So what we need to do, we need to entirely crop this sequence, and for the adapter content we will use the adapter file what we have. Okay, we are performing this. For we need to specify the directory. So this is our input file name, this is our output file name. We are writing the Illumina clip to remove our adapter content. So this is our adapter file for our read, that is the next error transpose sequence, and it is in the adapter. So we are specifying the path of the adapter file. Then our seed length, we can go with 30. Then we can use the sliding sliding window in here. Sliding, we are specifying the numbers. After that, we can use leading, failing. So for this read, actually, here we can see we need to remove these bases entirely. So for that, we need to use another command that actually head crop. So what's the difference between leading and head crop is leading check the quality. If it true, if the condition is true, then it trimmed. Otherwise, it keep that. But for the head crop, it doesn't have any conditional. So it entirely remove the first 14 bases. So if we run this now, okay, so I made a mistake. The tool name will be Trimmomatic. Don't actually FastQC. So here we can see the output. It actually contains, it read the adapter file first, and it found these adapter sequences in the file, and after that it said how much surviving and how much is dropped. So here this means it removed actually all the bases. We need to specify the parameters again. That is a little, we can remove this for now, we will use that later. Oh, okay, so here we use 40, that actually too high for as a mapping quality score. Okay, so that was the issue in there. So for this one, okay, so for this one, what we did actually here, for the sliding window, we specified the average mapping quality score as 40, and it removed all the read. It dropped all the read, and so the 40 as a mapping quality is very high. And after fixing that after lowering the mapping quality score to 20, so what we have now, it dropped 3.56% reads and 96.44% reader survive. So now if we check the quality of the trimmed file that we got in here, we specified the, and we want to get that inside the .qc directory. So this is the trimmed FastQ read, and if we look at here, so here we can see this is for the original file, and after trimming we got this one. So it contains now the total sequences after trimming, and we can see the sequence length here 22 to 87. And if we look go to the adapter content in here, we can see a little adapter content is still survive. So what we need to do, here we use this, that is 10, we need to lower this value. So if we use 7 in here, and if we run this again, we need to calculate the first case again for the output, and after reloading this, you can see the adapter content is totally removed actually in here, and these are not problematic, it's okay. So for the original file, we saw that all the sequence length was 101, and for here we can see it actually varies from 20 to 88, and other things are okay. So for the per base sequence content, first we had some fluctuations, you can see in here. So we can see some fluctuation in here, and we removed after the past 14 bases completely, and after removing we can see it doesn't have any fluctuation now. And for the this one, we can run the same command. So now we can so as it is a paired in file, so we can proceed with the paired in command. So how it will be actually, for the paired in command, we can specify in here. So we used SE in here, so we need to specify paired in here, and we already have the PH333. For paired int, we have two files, two input files. We need to specify read 1 and the read 2, then output for the read 1. So for the convenience, I can just write the command in here, so it will be, I'm explaining the command only. So, first the pair in read and the PH333. After that, we have two sequences, the read 1 and the read 2. These are the input sequences, and for the output sequences or output FastQ file, we will have two files for read 1 and two files for read 2. So for read 1, we will have one file that is trim paired.fastq and trim unpaired.fastq, and for the read 2, we will have same, that is first one will be paired and the second one will be, so you can see here, this is for the R1 read. For the R1, we have paired in paired and the unpaired, and for this one we will have paired and unpaired. So you can ask the question, why, what does the paired contains and what does the unpaired contain? Trimmomatic actually process each read, that is R1 and R2 file separately, and after processing, it trimmed some, it dropped some read from the R1 and dropped some read from the R2. And we told that at first every read in R1 has the mat or has the reverse mat in the R2. So after trimming, if R1 file has the mat, if that removed in the R2, that will be, so then that R1 will goes to the unpaired, and if it founds the mat in the R2 after trimming, then it will be written in the paired. So now we can copy the command in here. Okay, we can see what is happening in here.
You have opened the file. I think so you can cancel the file. FASTQ1 first when you read that will be fine. Permission is denied.
We have the file.
The file is open. I think so you can
Open.
Yeah, you can check in your system. The file is open. I think so. First SR1 file because the permission is denied. In your file after the build, yeah, here the file is open.
Okay, so here is the problem actually. We can see in here after the input read here, so we can check the both surviving. Both surviving means the read survived in R1 and in R2. So the percentage is 42.82%, and only forward survived, that is only the read from the R1 file survived, it actually 53.60%. For the reverse only survived, it actually 1.05%, and Trimmomatic dropped 2.52% rate. So after these are actually our main content. Both survive, that is written in the paired files, and we will perform our next analysis on this paired file. We can check the quality. For that, we need to run the FastQC. For that, we can specify the directory QC for the second paired file. So here we can see this file, and this file was generated. So we can in those. We can see the read one. It has actually no issue after trimming. This is the read one file, and this is the read two file. After trimming, it has the issue with the tile sequence quality. It actually fine that we have actually, and it removed the adapter content completely. So our trimming has been successfully done, and we can proceed for the next analysis. Now, if you have any question, you can ask. It was a long time actually. I think you may feel bored. Any question from anyone? So if you don't have any question, we can finish today's session. And for the assignment, I will just write them in the group. Okay, so we need to confirm by this summary section in here. So we expect to have the tick, and our most critical or most crucial part is actually the R-based sequence quality and the adapter content. So these two sections must have the tick after trimming, and we can see the read quality in here also. After trimming, most of every read has the high quality, and it's actually greater than 30. And for the adapter content, we see no read, we see no adapter, and for the this has for also the same. Almost every read has the mapping quality score greater than 28. Okay, the recording will be shared as soon as. Okay, so we can finish today's session. So what we need to do, you can, here is the ID. You can just extract the ID, SRR ID from the NCBI, or it will be more better if you extract a FastQ read by your own and perform these operations, that is FastQC and the Trimmomatic. After that, if you face any difficulties or if you can remove anything, just inform that in the group. We will figure it out. Happy learning.